Everyone, welcome back to SAT Math Question of the Day. We're trying to do difficult questions here from the SAT people. Here's our question of the day. Please read the question, pause the video, and we'll come back and do it. Okay, the graph of ax plus ky equals 6 is a line in the xy plane where a and k are constants. If the line contains points -2, -6, and 0, -3, what is the value of k? And it's a multiple choice question.
Okay, so here's how I came upon the solution. I read it.
Cheating. You're supposed to do it live.
And, well, I read it, and I realized it is a problem of two linear equations and two unknowns. The unknowns are a and k. And the two linear equations are the two equations you get when you substitute -2 and -6 for x and y in the expression they give you. And the second one is when you plug in 0 and -3 for x and y. Then you get two equations where the two unknowns are a and k. Now, that's so I thought if I formed those equations, then I would have to eliminate to get closer to the solution. And what I figured would be a good idea would be to eliminate x, because I want to find
A. You mean A.
I will eliminate a. Yes, I will eliminate a so that I could find k. And then I stared at these numbers, and I realized that the equation I get when I plug in 0 -3, 0 for x, I get an equation that only involves k. So I thought to my mind that one of the two equations is, what I thought on my mind is k times -3 equals 6, because a times 0 equals 0. So then I thought in my mind, okay, what k when multiplied by -3 equals -6, and that is -2.
Aha, right. So you noticed the pattern there. Yeah.
So I noticed the pattern, two patterns, two equations, two linear equations in two unknowns, where one of the unknowns is the unknown that it asks the value for. When a problem is like the pattern is where they ask for one of the unknowns, then an idea for solution is to eliminate the other unknown.
Of course, yeah.
Then the second pattern is that 0 times anything. So a is an unknown, but whatever it is, 0 times it equals 0.
Of course.
So that's the second pattern.
Right.
That leads us to one equation in which the a is gone because it was multiplied by 0.
Right, of course.
So it's one equation in one unknown, which is one linear equation, one unknown, which is immediately solvable.
Right. So Seth jumped in. I never really had a chance to do it. And looking back at the way I probably would have approached it if I saw it from scratch, is I probably would have done something really stupid. In hindsight, I would have tried graphing the points 0, 0, -3, and then -2. Oh, I see, -6. So one way to do the problem, which is really not the best way to do it, is if you have 2 points, you can write the equation of the line. And if you could write the equation of the line, boy, you would probably write it y well, I don't know, y equals mx plus b, and then you can move things around, and then you can figure out, then you can match coefficients. Not a
But before matching coefficients, match the constant.
yeah, 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 yeah,
Yeah.
yeah, yeah, yeah.
You have to multiply
So
you have to multiply the equation by the right number so that the b times that right number equals 6.
right, yes, 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 yes. So this is a very straight arrow approach, but it is time wise, you're going to blow a massive amount of time doing it this way. So when you're doing the questions and you realize, oh, I can do this, but it's going to take me a long time, you may want to stop for a second, take a break, and say, are they really wanting to have me spend 3 minutes doing this problem? There may be an easier way. And definitely the easier way is to do what Seth said, which is to put these numbers into the equation, into this, and then solve for, then you have two unknowns, A and K, two equations, two unknowns, and then you just do Seth. And then Seth said, yeah, it turns out that it's only one equation. It simplifies even further to be one equation, one unknown. That's the way to go. Just saying, our intuition is that when you do two equations, two unknowns, you always really go on autopilot and say, well, I have to solve for x and y, right? X and y. You always solve for x and y when you have two equations, two unknowns. But they switch it around, right? And here, the two unknowns
X
are
and Y. Oh,
the two unknowns are A and K.
So, dude, get out of that silly habit of thinking.
It is a silly
that
habit.
When you have two equations and X and two unknowns, you always solve for X and Y. No.
Well, that's not true. That's not true.
It is absolutely true that we have two equations and two unknowns. The names of the unknowns are completely unpredictable. They're not X and Y.
Right. Yeah, that's right. Yeah.
So don't remember what Joel said. When you have two equations and two unknowns, they're usually X and Y. No.
They are usually X and Y.
No, they aren't. They shouldn't be.
Seth.
You should get it out of your mind, because the challenging questions is when they change. When they change the stupid habit that people get into.
That's right. That's exactly my point.
So you have to get out of that habit of thinking X and Y.
No. The reality is that most of the time, two equations, two unknowns are most of the time generally X and Y. Most of
Not
the time.
In life.
What? Okay,
not in science.
Okay, Seth, stop.
In the mind, in the concept, and in real math that's used by scientists.
Seth,
the unknowns come from the problem.
Seth, look at our audience. We've got to view everything from the point of view of the people who are 11th graders practicing for this.
Well, 11th graders need our audience is those 11th graders who've seen all this X and Y stuff, and our audience is people who want to go beyond the average and get top scores.
Yeah, you just said it yourself. That most of the people our audience are used to X and Y. You just said it yourself. Well,
most of those people see X and Y, and we are telling most people, who are most of the people watching this, that this is a habit that you need to change.
Absolutely right. Absolutely correct. Absolutely, you have to be open for the idea that the two unknowns may not be X and Y. May be something else and something else. Absolutely
like A and K.
Like A and K. And it doesn't matter, J and G, F and P, right? If you have two unknowns, and you have two equations, in those unknowns, you have two equations, two unknowns, and you deal with those as is it solvable, not solvable, whatever. Yeah, right. Yeah, that's like the hurdle. That's the little twist that the SAT threw in this. Yeah. This is also a very useful method if they give you 3 points and you want to know the equation of the circle. You can do this also. You put the 3 points into the circle equation. Same thing you do for parabolas. You can have 3 points. You put the 3 points in. You calculate the three unknowns in the parabola. In the parabola, you have y is equal to ax minus h squared plus k. Three unknowns in a parabola, a, k, and h. You need 3 points, and that locks in 3 equations, 3 unknowns for the parabola. So it's exactly this problem, except it's in a line. So the intuition, though, they're really tempting you. They're not the intuition. The straight arrow approach is to draw the line, get the equation of the line, and match coefficients. Oh, what a time waste. Oh, my God. So this is such a pattern question. And that's one of the reasons why it's marked as difficult. We're only doing that right now, starting now. For a while, we're only going to be looking at difficult questions for the SAT.
Yes, it's marked difficult. It's difficult because it breaks the pattern.
No, it's also tempting you. It's tempting you to do it this way. It's tempting you to do it the straight arrow approach. Take 2 points, write the equation. By the way, they give you the y-intercept. Well, that's very nice of them. So in other words, it's relatively easy to write this equation. You just have to get the slope. So it's y is equal to the slope x minus 3. So it's easy you can get the slope here. Of course, it's positive, and you can do it. What is it? It goes up by 3 when it goes across by 2. So the slope is 3 halves. So y is equal to 3 halves x minus 3. So, it doesn't take that long, but it uses up a lot of brain power. 2y is equal to 3x minus 6. Oh, that's nice of them. They give you the 6. So then you do negative 3x plus 2y is equal to negative 6. So that's right. This is it. By the way, it didn't take us 2 minutes. And then you match these two. There's a 6 here, positive 6. There's a negative 6 here, so the coefficient in front of the 2 is negative 2. No, that doesn't ever take that long because they were nice that they gave you the. It's nice that they gave you the y-intercept. So it really didn't take that long to do it straight. It didn't take that long. 30 seconds? But it took more brain power. But the clever way of doing it is to make it a 2-equation, 2-unknown problem. So. Yeah. Wow. So these problems, now that we're looking at what's called the difficult questions, we get these from the Educator website on the SAT.
One thing you might notice, without thinking of it as what you could, some people might have noticed directly that. Use purple, but directly. This is one fact, and this is one fact.
Right, you're using
this is the equation for a line, and this is a point on the line. And so when this pair of x and y satisfies the equation. The x is 0. The y is given. So you could find k.
Right. Yeah. You can see.
So if your eyes, without working, the truth is, when I read the question, I thought of how should I solve it. I thought, okay, eliminate ax. That's my thought. But then I started staring at what information I was going to use for eliminating it, and at that point I noticed that this pair is special because the x was 0.
Right.
And so I realized that you could just get ky equals 6.
But you didn't really have to stay. You could have started what you did. You could have done negative 2a minus 6k is 6. And then the other one would be, look at me. Oh, my God, look at this. And then you realize right there. Yeah. The other thing, I don't think.
Yeah, you could have written, if you had written this.
Yeah.
If you had written this down, might have immediately seen from the second equation that you could immediately solve for k.
For k, yeah. yk, negative 3k. See the habit I put in negative 3y? It's a
Yeah.
tough habit to break. It's a tough habit to break.
Yeah.
The other
Yeah.
thing that I don't think is that great of a way to do it is this is in what's called standard form, and standard form is useful for the intercepts. You could pick the intercepts off standard form in a second if you don't get your x and y's confused, like I always do. So A and K are the intercepts, and then and then you realize, there is an intercept. But then you have to think about which intercept and which one is zero, and the x and the y, because the y-intercept is when x is zero, the x-intercept is when y is zero, and your brain gets completely confused. What am I doing? Especially on a time test with pressure. So that's another way of thinking about it. If you recognize these, the A and the K are the intercepts in some way. So anyway, so they're different. Like most difficult questions that are marked as difficult, there are different ways to do them, different approaches. But maybe in terms of overall strategizing, if you realize the problem requires a lot of work, there's just sort of like a lot of work involved in this method. You may want to take maybe 5 seconds, but maybe no more than that, to say, well, maybe there's a faster way. So there's a pattern here I'm missing, so that I don't have to do all this work.
Okay, the A and the K are not the intercepts.
Oh, A and the K divided by 6. But they're related to the intercepts.
No. 6 divided by A.
Yeah.
Is the x-intercept.
Right.
X.
They're related. I should have said they are related to the intercepts. A and K.
The x-intercept is when y equals 0 is 6 divided by A.
Right. Okay.
And the standard intercept form is x over...
Seth, we can't see you. You have to go down. You're above the
line.
Oh,
sorry, yeah. The standard intercept form is x over...
I still can't see your writing.
X... Oh, I'm sorry. Oh,
you have to go below this line. You have to go below that blue line. See the blue line?
Okay, good. So
now it's it's
all smushed up. There's no room for writing more stuff.
Okay. Here, let's give you some A and K of the unknowns. Okay, how about
that? Okay. The intercept form is... The intercept form is x over x-intercept plus y over y-intercept equals 1.
Oh, okay.
And therefore, if the equation is ax plus ky equals 6, then the x-intercept is equal to 6 divided by A.
Right, okay. Right, so I was wrong.
Intercept is 6 divided by A.
I was wrong. A, K,
we don't want to put wrong information on YouTube.
You're right. That would be the worst thing in the world. God forbid that. No,
well, there are worse things than that.
Okay, but no, A and K are not the intercepts. A and K are related to the intercepts. A and K.
They're the reciprocals.
Yeah, A and K have.
When you normalize the constant, and of course, what happens is if the constant is 0, the two intercepts are both 0.
So let's say you memorize. Let's just say you memorize, which don't suggest doing that. The y-intercept is 6 over b. So then you would write, 6 over b is the y-intercept, so that's -3. And then you could immediately solve for.
Well, the cool thing about the intercept form,
then you can immediately
that
solve
when we go a little bit beyond and look at ellipses, an ellipse that's centered around the origin, it has x-intercepts and y-intercepts.
Yeah.
And the standard form for the ellipse, the intercept form, is x over x-intercept squared.
Right.
Plus y over y intercept squared equals 1.
Right. Yeah. So it's like, yeah. Yeah. So
And then if you change the plus to a minus, then you get the intercept form for a hyperbola.
right. Yeah. Yeah. Which looks like this.
And when we have the intercept form for the ellipse, and x intercept equals y intercept, then you have the intercept form for the circle.
Right. Yeah.
Yeah.
Okay, so let's do our questions. So is there a pattern to this? Oh my goodness, there is a pattern to this. If you recognize that you can use this and plug it directly into the equation, you get the answer instantly. If you see that pattern, you get yourself an extra 30, 40 seconds on the SAT, which is invaluable. So there's definitely a pattern to this question. And the main idea here, well, boy, to be cynical about it, the main idea here is they're testing. Do you recognize that there's a real fast way to do the problem as opposed to the straight arrow approach? That seems to be one of the main ideas that the test takers want to see, are challenging you. Are you going to see the faster way of doing it? But less cynically, the main idea here is using 2 points to get the equation of a line and comparing the equation of a line to this to pick off the constants. Or the other main idea is recognizing that if you have a point on a line, you can plug the point into the equation and go from there. But there you'd have to recognize that the unknowns are a and k as opposed to x and y. So those seem to be the main ideas. We talked about that. Starting with the answers, you can't back solve. You sort of can, but no, you can't really use the answers to get the answer. You can't really start here and go back. Is this different from a school test? Yeah, you don't usually get questions like this in school. Calculator definitely doesn't help too much. It really doesn't help at all. And so those are the 4 questions. Anything else, Seth? Oh, you know what else we could do? Now that this is from the educator side of the SAT, we can actually do what Seth likes to do the most, which is critique the answer that the SAT gives on how they suggest we do the problem. Okay, ready? Good. So this is what the SAT people say. So let's see, do they go the straight arrow approach or do they do the other approach? They really should show both. Oh, wow. No. Oh, look at this. The value of k can be found by using the slope-intercept form of the linear equation. Oh my goodness. One of the points is the y-intercept. That's the y-coordinate. It must be k. Wow. So they're using another way of doing it. We talked about this method. This was one of the last things we talked about. That's really too bad that they don't mention the method, which is the most powerful, which is if you have a point, you could plug that point into the equation and see what you get.
Yes.
Oh, that is really not good. That they don't offer that as another option.
It's horrible.
It's horrible. Absolutely horrible. What are they thinking? Do they not want people to learn how to do problems in creative ways? What are they thinking?
I'm afraid so.
What are they thinking? They're completely irresponsible for the SAT not to offer option 2. Because option 2 is what you're going to need for more difficult problems on the SAT, for which this method, the method they're doing, is going to be too long to do. You have to know that. Oh, this is really annoying, right? Suddenly, even I'm getting upset. You have to know that if you have a point, this point can be put into the equation. 0x, minus, a0 plus k negative 3 is equal to 6. Being ready to do this on any problem, no matter what function it is really important and really help you.
Really dumb what they did.
Their
approach is to take the equation that they give you for a line and transform it into slope-intercept form. Without using any information about A and K.
Yeah,
Well,
right.
now that fails because without further information about A and K, K might have been 0.
Yeah.
In which case, there's no y equals mx plus b form.
Right. Yeah. 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 Yeah.
Yeah.
Wow, this is really disappointing.
It gives me doubt. It makes me doubt the mathematical competence of the person who, or people, or committee who wrote this stuff.
You mean wrote the solution, but not wrote the question?
Yeah, wrote the solution. Yeah.
Yeah, but the question is really clever.
Yeah, the question's great. Yeah.
The question is really clever. Yeah.
Yeah.
Well, they don't usually. Well, we're going to look because we're going to be doing this for a while. They don't usually offer alternate solutions.
Yeah.
But when you're studying, it's important to try to find alternate solutions, but also look at and this is what we're going to try to do, is we're going to try to really get to some of the really ideas of math, of these types of problems.
Okay. Well, I think, actually, let me apologize to them.
Okay, go ahead.
What it would have been much better if they took this sentence. One of the given points is the y-intercept, and they put it over here.
Okay.
And then so they took this and they put that there, and that would motivate. This would motivate this motivates the use of slope-intercept form.
Yeah.
Why? Because we know from this that -3 is the intercept.
Yeah.
-3 equals the intercept, which is 6 over k.
Don't go
when
above
you put
this
it into
line,
slope-intercept form.
Seth, you can't go above this line.
Okay. Sorry, I forgot. So I circled this.
Yeah.
This circle motivates. So what they should have done is say choice A is correct, and then they should write one of the two given points is the y-intercept. That's the second sentence. And then the third sentence, the value of k, can be found using the slope-intercept form. Okay?
Right, but if you have y equals mx plus b, and one of the points is the y-intercept, then that means -3
equals b
is equal to b.
Yeah.
Then you have to look back at the form of the equation. What was it? It was ax plus ky is equal to -6.
Yeah. So what they did was you give. This is what's given. This is what's given. And so their strategy is to rewrite the given into slope-intercept form. Y equals mx plus b. And therefore, you could then, by doing slope-intercept form, you could see that after rewriting it into the form, you see that the y-intercept is 6 over k, and they tell you that therefore the y-intercept is -3, which is equal to 6 over k. And what's k? It's -2. So their approach is what if the writing. It's just maybe it's not a matter of a stupid approach, but it's a matter of not leading the reader, not showing the reader the thought process
Yeah.
to figure out how to approach the problem. So it led me to think it's teaching the reader, it's informing the reader that whenever you see an equation that's not in slope-intercept form, change it to slope-intercept form.
Right.
Which is not, that's not a good idea.
Well, you have to be flexible.
If you know the intercept, then it is a good idea to convert it to slope-intercept form.
Right. Yeah.
So they should say first, the problem tells us the y-intercept.
Right. How can we use that?
Let's convert the equation into slope-intercept form.
Right. Yeah. So here's another way to do it. You can write y equals mx plus b. Knowing that it's in y-intercept, you immediately know b is -3. Then you do some algebra, which is a little creative. You rewrite y. Then you have to get it in this form. So you move the mx over to the other side, and it's -mx plus y is equal to -3. But we're only interested in k, so we have to match these things. And we realize that k is equal to negative. In order for this to be true, k has to be -2.
Okay.
So that's another way of doing it.
Yeah.
They love the SAT. It's pretty obvious, pretty clear. The SAT people love equations with coefficients in them and figure out what those coefficients are. These problems are all over the place. If you have 44 questions on your math SAT, you could you could have at least 10% of the questions are going to be like this, where you have to solve for a parameter in the equation, some unknown in the equation.
What could you do with equations? One is if they give you an equation, you could say something about its solutions, either geometrically or algebraically. What else can you do? Besides the opposite, they give you information about the solutions, geometrically or algebraically, and then you have to figure out what the equation is.
Yeah. And there are different.
And figuring out what the equation is the same problem as figuring out the unknown coefficients in some standard form.
So that's why it's so popular.
So that's why besides one half of the subject is solving equations. The other half of the subject is finding solving an equation means finding the solution. The opposite is given a solution.
Right.
Given these solutions or information about the solutions, find the equation.
Right. So I have it right here on the left. Writing equations given the solution. It's the backwards question. That's why there's so many of these on the test, because it's the backwards question of solving an equation. It's writing the equation given the solution. Right. Yeah.
Which is it's important. Both are important because often in applications you want to do what's called a mathematical model.
Yeah.
Where you want to find an equation
Right.
that whose solution is data that you're given.
So this is why these problems always seem harder, because the backwards question in general is always harder than the forwards question. Uh, yeah. So
Hmm.
that explains sort of like, yeah, they can't give too many easy questions. They have to give some hard questions. So, of course. So, yeah, so be ready for it. So that's a good point of view. Is this is a question where you, given the equation, solve it, or given the solutions, find the equation. Right. Yeah. So that explains why at least 10% of the test is going to be this, which is going to end up being a parameter question. What is the k of this equation? Okay, I think we are seriously done, and I hope people get something out of this. But this stuff is really important stuff. So sorry it takes so long to go over, but try to absorb what we talked about today. It's really sort of important stuff. Okay, so I guess that's it, right?
Yeah.
Okay, so please give us comments on our videos. We take comments very seriously. We try to respond to everyone. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. And in terms of studying, just go to Blue Book and take as many Blue Book tests as you can, and just search the internet. And you'll see many people comment that the actual digital SAT is usually harder than the Blue Book questions. So just be ready for that. You can do all your research, searching all that on the internet. There are people who can talk about that better than we can. Okay, everyone. So everyone, have a great day. Take care.
Okay.